Okay, so it's got a whole lot about the question here. I'm going to put the forces in green because you know I always do anyhow. So we've got those two. It says that's RA, it's given in the question. That's RB. It's a rough horizontal table, so there's going to be FA going inwards there and FB going that way, and it's here there's going to be force acting on one way and equal and opposite force acting on the other one. So that says that if I'm going to take moments about something, those ones take the moments of the whole object, then I'm going to get rid of that because they'll be equal and opposite, and so I don't need to consider that, the internal forces. But if I'm going to take moments about for one of the rods or the other rod, I will want to take moments about here, because then I don't have to worry about that, because both those forces go through that point at X. So that's the first thing. And we've now got to show that RA equals 125. So we've got to show that this bit is 125. So we're not interested in this bit here. If I were to take moments about X for AX, then what would actually happen? I'd get rid of this bit, but I'd have the RA in there, and I'd also have FA in there, and I don't want that. I want to find a place which I can find RA, but not include FA. And the obvious thing to do is do it somewhere along this line here. And actually, if I do it here, RB goes through here, FB goes through here, FA goes through B. And so therefore, I'll only end up with these two I know. This will be an internal force because it's the whole thing. So they have an equal clockwise moment and an anti-clockwise moment. So that's what I need to do. So the first part, for part I need to take moments about B and for a whole object. And this is going to give us the anti-clockwise moments equals the clockwise moments. So what have we got which is anti-clockwise? We're doing it about there. Anti-clockwise, this one is going to be anti-clockwise. So that's going to be 130 force times by the distance, and I've got to find out what that distance is. And I've got no angle here. I could work out what the angle is, but actually this weight is a uniform rod, and so this weight will act in the middle, so that will just drop straight down there, and this distance is 0.5, so that will be 0 times 0.25. What else which is anti-clockwise? Well, this 150 newtons, so we've got plus 150 times by what distance is that? Well, that's going to be halfway, it's going to be the 0.5, and then it's going to be halfway along this, so it's 0.45, so that'll be times 0.95, and there's nothing else anti-clockwise, so what's it going to be clockwise is RA times by the distance is that distance there, which is 1.4, and that says that RA equals 125 newtons. Yeah, you can work that out. So I've now found out what RA is, show that equals 105, and find RB. You could take moments. I could take moments about here, but moments are always a little bit trickier. So generally rule, you take moments once, and then you resolve vertically, or indeed horizontally. But resolve vertically for the whole object. And do that, we're going to get what's going up, 125 plus RB. So basically we're doing upwards equals downwards, and that equals my 150 and the 130, and that says that RB equals 155 newtons. So that's done the first part. Now the second part, find the frictional components of the contact forces acting on the rod A and B. Why don't I find out this one first? So FA. Now if I can do that, I can't take moments about here. I can't resolve horizontally. Well, actually resolving horizontally would be great, because I get FA equals FB. So it's internal forces will cancel each other out. So FA must equal FB. So all I need to do is find out what FA is to get there. And so I want to have things, I of course do know that RB, or RA rather, equals 125 newtons. So I actually know this one now. That's 125 newtons. So what I'm going to do is take moments about X for AX. And what have we got? So I'm going to have anti-clockwise equals clockwise. What's anti-clockwise about that? That'll be the 150. So it's 150 times by the distance there, which is half of 0.9, so it's 0.45. Plus, what else? We've got the FA. FA times by how far is FA from this? Well, it's the line of action of this, which goes all the way along here, and it's 1.2 distance from there. It's times by 1.2, and that equals my clockwise moment, which is RA, which is 125, times by the distance that is, which is 0.9. And that gives me that FA equals 37.5 newtons, and therefore FB equals 37.5 newtons, and that is by resolving horizontally the whole thing. That's what I said earlier on. And we have got now the third thing we've got to do is find the horizontal and vertical components of the force exerted on XA at X. So we've got, if I look at AX, goes like so, and we've got this one goes 125 newtons upwards, and it goes 37.5 newtons acrossways, and we've got this bit coming down here, it's 150 newtons going down. What's happening up at the top here? Well, pretty obviously it's got to be a bit. I've got 25 coming, an extra 25 coming down, so there must be 25 newtons going upwards, and there must be 37.5 newtons to the left, and that's all I really need. So 25 newtons up, 37.5 newtons to the left, and put that in words, but that's for you to do. That's 5 done.